So, in order for me to better explain what this means, I gotta start out kind of like with something that you already know how to do. So, let's say that you have something as this. You have 3 over x plus 4 plus 2 divided by x minus 3. What would you have to do in order to solve this problem? You need a common denominator, right? So what is that common denominator for this problem?
X plus 4 times x minus 3.
Very good. X plus 4 times x minus 3. In order for you to achieve this, you need to multiply the 3 by the x minus 3 and the 2 by the x plus 4. Are we okay with that? So then at this point, what you're going to do is you're going to go ahead and multiply things out. So on the numerator, you're going to have a 3x minus 9 plus 2x plus 8. And on the denominator, you're going to have x squared minus 3x plus 4x, so it's going to be plus x minus 12. Cool? So if I clean this up, I'm going to combine like terms. I have 3x and 2x. That gives me a 5x. And that gives me a minus 1. And this is going to be all over x squared plus x minus 12. And that should be my final answer. Cool? Are we okay with that? Can you do that? Well, hopefully you can. You know, this was something that from the beginning of the year, I think that was something that we hit at the beginning of the year. That is definitely something that we hit at the beginning of this unit. Because here's what's going to happen. So this should be relatively new. You've done this before where I give you fractions and I ask you to add them or subtract them. And you should be able to get one fraction. But in mathematics, if there's a way to get from here to here, there has to be a way to go from here to there. So what we're going to do is called partial fraction decomposition. What it means is that you're going to take a fraction and you are going to decompose it or break it apart into several fractions. Okay? Could there be more than one answer? What do you think?
I think so.
Yeah, there could be more than one.
So do you think there's, like, for example, I mean, I came up with these two fractions. Do you think there's other two fractions that I can add that would give me the exact same thing? Kind of unlikely, guys. It'd be kind of difficult to achieve that. Okay, maybe, well, actually, not really, guys. Think this through, because like, there's no way we're gonna get another two factors that's gonna give us the same thing. You guys with me? So based on this, if I kind of work backwards, there's no way that this numerator would be different based on that. Which means that there's no way that this could be different, and there's no way that this could be different. Okay? So unfortunately, no. Like, there's only one way to break apart those fractions. Okay? So, in my opinion, this is not going to be a difficult process algebra-wise. What's going to be difficult for you guys, personally, what I've seen in the past, is that you guys get stuck in the arithmetic. So you're going to have to be very careful in your arithmetic. Okay? Now, how are we going to do this? Okay, well, let's analyze kind of our process going forward and then kind of going backwards. So if you started here, you first did, well, let's get a common denominator, right? So you're like, okay, let's multiply each other, and that's where you got this, and then you multiplied everything out, so then you went here, right? What do you think I'm going to have to do first to this expression if I want to go backwards?
Factor the denominator.
Good. So, step one, you are going to factor your denominator. Do I need to factor the numerator? Do you guys think?
No.
Not necessary. Really, you just have to factor your denominator. Okay? Alright, and this is where it gets, unfortunately, a little tricky, and not really. Well, actually, I forgot one thing. Let me make sure I go back. Your fraction, before you begin, you have to check that your fraction is proper. Do you know what it means to be proper?
The denominator is bigger
Good.
or higher than degree.
The denominator must be bigger than the numerator. If it's not, guys, then you have to make it proper. Do you know how to make a fraction proper? You did this in elementary school. You would make it into a mixed number. Like, for example, you have 5/3, that's the same as 1 and 2/3, right? So if you have a fractional function, because we're not dealing with just numbers, you're going to have to make it proper by division. Okay? And we'll get to an example when at some point today. Okay? Now, here's the catch, guys. In order for you to do this, after you factor, there are several cases, and that's just what they call it. But to be honest with you, there's an infinite amount of cases. Okay? Because everything depends on your factors. Cool? So we're going to just talk about 4 cases in this class, and we're not going to talk about all 4 cases today. We're only going to talk about 2 of the cases today. So, and then step 2 is, depending on factors, follow the appropriate case. Okay, so case number 1 would be what we call distinct linear factors. Okay, do we know what the word distinct means? Different. So case 1 is basically saying if you factor out your denominator and all the linear factors are different, then you're going to do the following. You ready? Okay, so I'm going to show you the math, and then we're going to show you an example. So if you have a numerator and then you have a denominator, and you figure out that that gets broken down into, I don't know, x minus a of 1 plus x minus a of 2, and you can have as many as you necessarily, well, it all depends on how many you have, right? So you can have, I don't know, up to n factors. Cool? What's going to happen is on the numerator, you don't know this, you're going to use variables to help you out. So we're going to call this capital A of 1, capital A of 2, this will be capital A of n. Where A of 1, so A of 1, A of 2, dot, 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 A of n are constants. Okay? And they have to be real numbers. Okay? Why does this work? It's hard for me to explain to you without calculus. So at this point, I'm going to ask you to trust me why there has to be a constant on the top. So in other words, what this is really saying, case number 1 is, if all of your factors are linear, there should not be any variables on the numerator. It's just going to be numbers. That's really what case 1 says. Cool? So, let's try out the example that we just did. We should be able to take this, and we already know the answer. So let's make sure that we can do it, right? This would be a case number 1. As you can see, the factors are different, all right? So let's go ahead and try that one. So,
wait, Mr. Curion, could you go back to the other page for a second?
Sure. All right, so let's go ahead and try the example that we've already kind of done, so we should know the answer. So we're going to decompose. All right, step 1 is going to be to factor the denominator. So the denominator for this is going to factor into x plus 4, x minus 3. Cool? Now, if you look at the rules from case 1, really what you're going to do is that, you know how the rule says that you put as many fractions, like you can have nth fractions. Well, in this case, you have 2 factors, which means you're going to have 2 fractions. So in this case, we're going to say that's equal to, one fraction is going to have the denominator of x plus 4, and the other fraction is going to have a denominator of x minus 3. The order in which you do those does not matter. Like, for example, you could have chosen to do x minus 3 first and then the x plus 4. Cool? Now, case 1 tells you that even though you don't know what the numerator is, you are guaranteed that they're going to be constants. So here's what I suggest. You can call this constant A, and you can call this constant B. I just don't recommend that you use x and y. You with me? You can use any other letter that you want. So here's what I know. I know that 5x minus 1 over x squared plus x minus 12 is equal to that. Do you guys agree? That's what I'm trying to figure out. Cool? Now, this is where basically you're going to go back to, you know how to do this, right? If these two fractions added together are equal to that, then that means that you actually have to add these fractions, right? You guys with me? So in order to add fractions, you need a common denominator. Agreed? So basically, you're going to redo what we did at the beginning of class, which would be get a common denominator between these two fractions, which would be x plus 4 times x minus 3. And on the first one, you're going to have a times x minus 3. And on the second one, you're going to have a b times x plus 4. Cool? Any questions thus far?
So for the part where it's like A and then B,
Mhm.
with the x minus 3, is it okay if we flip it? Like,
Yep.
can we have like A, x, does it matter?
It does not matter.
It does not.
No. Your work is going to end up being the exact same thing. I promise. Cool? All right, so now, question for you. Based on where we're at, for fractions to be the same, you have to have the same numerator and the same denominator. Agreed? What have you already achieved at this step? You have the same denominator. So, for the rest of the problem, I don't care about the denominator. Agreed? Here's all I care about. I have this. 5x minus 1 is equal to a times x minus 3 plus b times x plus 4. Are we okay with that? All right. Now, I am going to show you two ways of solving this, and then you pick up how you want to do this. Method number 1. You're going to distribute everything out. So this would be, okay, by the way, this is using a system of equations. Do you guys remember what a system of equations is?
Yeah.
It's when you have two or more equations. So if you have two equations, you have two variables, two unknowns. If you have three equations, three unknowns, and so on. So the first one would be with the system of equations. So first, I'm going to multiply or distribute the a, so it'll be ax minus 3a, and then it will be plus bx plus 4b. Are we okay with that? Now, second step, I'm going to rewrite this in order. So I'm going to have ax plus bx minus 3a plus 4b. Now I'm going to be showing more work than I typically show, but it's just because it's the first day. Right here, I'm going to factor out an x, and I'm going to have a plus b. And I'll let you catch up. All right, so here's my question to you, and I want you to really think this through. If you actually knew what a and b was, right, then you would just be able to add them together. Agreed? Now, what does this a and plus b have to be equal to in order for this to be true?
5.
Good. So that's your first equation. A plus b should equal to 5. Does anyone not understand why that is true? Why a plus b should be equal to 5? Okay, what about this negative 3a plus 4b?
That's equal to negative 1.
Good. So this negative 3a plus 4b should be equal to negative 1. Why? Because remember, a and b are just constants. So if you just multiply them by another constant, they're just going to give you a constant overall, which should be equal to the constant on the left side. And now we have a system of equations. We have two equations and two unknowns. And this lesson is not about teaching you how to solve a system of equations. There are several ways of doing this. You can solve a system of equations through substitution. You can use it with addition or subtraction. You can use a matrix. At this point, I'm not really going to show you the methods of doing it. Whichever method you prefer, I'm okay. I can follow any of the methods that you want to do. So in this one, I mean, it's really not that difficult. I think I'm going to use just substitution. I think that would be the easiest, personally. Well, actually, I'm going to multiply this by 3, which gives you a 3a plus 3b equals to 15. Are we okay with that? And then I'm going to put this here, 3a plus 3b equals to 15, and I'm going to add those two expressions. Negative 3a plus 3a goes away. 4b plus 3b gives you a 7b. Negative 1 plus 15 gives you a 14. Therefore, b is equal to 2. Are we okay with that? And now that I know what b is, I can go back to this previous statement without the 3, so a plus b. So I know this would become a plus, the b in this case is 2, is equal to 5. So a is equal to 3. So we've got a and we've got b. Questions with any of the mathematics that I did as far as the system of equations go? Alright, and this is typically where I would take points off because you think you're done. You're not done. Your answer is not a equals 3 and b equals 2. Your answer is this fraction, remember? So now you got to finalize it. A is equal to 3 and b is equal to 2. So that means your final answer should be 3 divided by x plus 4 plus 2 divided by x minus 3. That's your answer. Okay? And that is what we had started with. If you kind of go back into your work, remember one example that we started this, it's exactly the same thing that we started with. Okay? Alright. Questions about how to solve this with a system of equations?
Is the reason a and b are constants, is it because the bottom is a quadratic, or?
No, it has to do when this step right here, once they're broken up, it's actually because the denominators are linear. The calculus explanation of that, you may not understand it, but I'll go ahead and tell you, is that the derivative of a linear is a constant. Therefore, that is the reason why you have a constant on the top.
Okay.
Cool. And then if you take calculus next year, you'll probably understand more what that means. Cool. All right. The other way of solving this, which is actually my favorite, I don't have anything against system of equations, but they can get complicated. This was an easy one. Would be to count. Yes.
What's the first case called again?
Distinct linear factors.
Okay.
Cool. Now, same problem. Let's go back to this statement where we got to this statement right here. Let's say that you're like, you know what, I don't want to do a system of equations. I've never been good at system of equations. I don't want to risk it. Well, there's a way out. Cool, so let me rewrite this on the next page. So we got 5x minus 1 is equal to a minus 3 plus bx plus 4. Okay, I don't really know what to call this method. It's just something that I thought at some point I was like, this is just easier. And if you like it, great. If you don't, then use the system of equations. Okay? Here's what I thought of. Look at this expression. Can you think of an x value that would make something go to 0? On the right hand side, I'm sorry.
-4.
-4. Here's what I'm going to do. I'm going to plug in x equals -4 everywhere. You with me? Okay. So if I do 5 times -4 minus 1 is equal to a times -4 minus 3 plus b times -4 plus 4. Cool? 5 times -4 gives you a -20. Minus 1, it gives you a -21. Cool? -4 minus 3 gives you a -7, so that times a, that gives you a -7a. And -4 plus 4 makes the b go away. Cool? So then if I divide both sides by 7, that gives you that a is equal to 3. Which is the exact same thing we obtain through the system of equations. Agreed? Do you see where I'm going with this technique?
So
You're
you're just plugging in the values that make 0 so it cancel out the other A or B.
Exactly. You want to, instead of having two unknowns, which is what you have right here, if you're able to get rid of one of them, then you should be able to solve. Cool? So what would be the other x value to try for this?
Positive 3.
Positive 3. Okay, so that would be 5 times 3 minus 1 is equal, I'm going to go ahead and skip some steps. 3 minus 0 is just 0a, right? So this is gone. So 0a. And then 4 plus 3 is 7, so that would be 7b. So we got 5 times 3 is 15. Sorry?
I have a question. So, like, whenever you did plug in -4, we got A equals 3. Oh, right, sorry. I was thinking of B for a second. Never mind.
You're good. And then 5 times 3 is 15, so minus 1 is 14. So 14 is equal to 7b, which means that b is equal to 2. And we got the exact same values as if we would have done a system of equations, and we didn't have to worry about actually performing a system of equations type of scenario. Which, once again, all right, the one we did for this problem, the system of equations, was pretty easy in my opinion. I think everyone, if you're taking this class, should be able to handle that type of system of equations. However, personal opinion, I think this is easier than a system of equations. Cool?
Wait, carry on.
Yes.
Will that work in every scenario, or is it just, or does it only work with like certain scenarios?
It works with most of them. And what I mean by that is that as long as you can find something that makes this equal to 0, it should work. If there's not a number that would make this go to 0, then it's not going to work. And that's going to be probably until next class. Everything we're doing today should work. Cool?
Okay. Okay, thank you.
I do have another question. If you, for the first one, if you did find A equals 3, couldn't you just plug in 3 for A?
Yeah, absolutely. Yeah, you can, at this point, the more basically, the more problem solving you use, you can just use that. I agree. Once you found 3, like you could have gone back here, you could have plugged in 3, and then you can find B after that. You guys with me? It's totally up to you guys how you want to attack this problem. I'm trying to give you as many tools as I can, and then just make sure you utilize them how you see fit. Cool? All right. We're going to do one more together, and then I'm going to let you do one on your own. I'm sorry, did somebody ask something?
Yeah, I had a question about the test. Like, what would you put for the answer? Because technically your answer is the same as the question, right?
Yes, well, I mean, look, let's just start off to make sure that you're not confused, okay? Like, today we started with this, right? That wasn't the question. That was just me making sure that you know how to do this, right? You can you add fractions and get here? Cool? The question that I'm going to ask you on the test is going to be like, can you decompose that? Now, we did an example that you've already kind of knew the answer to, so you knew what the answer was. You with me? So let's just do one that you have no idea what it looks like, so that you have an idea what it's going to look like on the test. Cool? All right. So, example number 2. We are going to decompose the following fraction. We've got 3x divided by x squared plus x minus 2. All right, so you guys help me out. What would I do first?
Factor out denominator.
Cool, factor out the denominator. Now, notice how it's a quadratic. I'm going to get 2 factors, so that's the reason why I already wrote 2 different fractions. Cool? What are those factors?
X minus 1 and x plus 2.
X minus 1, x plus 2. Do you see how they are linear and they are different? Based on that, we need a constant here and we need a constant there. Cool?
I have a question.
Yes, sir.
So, if for this case, right?
Mhm.
Since we know the denominator is like linear,
Yes.
what couldn't we just know that a and b have to be constants because it has to be that or lower?
Correct.
Okay.
Yes, sir. Cool. All right. From here, what do we do, guys?
We give a common denominator.
We get a common denominator. Now I'm gonna skip one step, right? The common denominator is x minus 1 times x plus 2. Do you guys agree? At that point, I'm going to have the same denominator as here, right? So we don't really care about the denominator anymore, right? All we care about is the numerators, right? So what would be the numerator for that fraction on the right?
B times x minus 1.
Uh-huh.
And then it would be plus a times x minus 2. Plus 2.
Plus 2. Are we okay with that? Are you okay with me skipping the denominator? If you're not okay with it, then write it down. It's not a big deal. Cool? All right. Now we're here. So my question to you is, what do you want to do? A system of equations or just, I don't really know what to call the other method, honestly.
The other method.
The other method? Good for you. All right. What would be a good x value to try?
1.
Negative. Oh,
A 1 and what else?
negative 2.
Cool. So let's just go ahead and do both. So we got 3 times 1 is equal to, all right, if I plug in 1, that goes to 0. And then if I plug in 1 right here, that gives me a 3a. Cool? So based on that, a is going to be equal to 1. Right? Cool. If I plug in negative 2, that's going to give me 3 times negative 2 is equal to negative 3b. And then that's going to go to 0. So that gives me negative 6 is equal to negative 3b, which means that b is equal to positive 2. We okay with that? So now what's my final answer?
1 over x minus 1 plus 2 over x plus 2.
What if you wanted to check your work? What could you do?
Combine it.
Yeah, you can actually add them. And then you should get this, right? But I'm going to go ahead and be honest with you. You're going to have to trust your work. You're not going to have time to do all that. You can do it on the homework if you want to like check your work. But on the exam, you're probably not going to have time to actually add the fractions so that you can get to verify that you actually have the correct numbers on top. Cool?
So
All right.
on the test, would we just be doing linear ones, or
No, my
would
friend.
we have all of them?
No, this is just the first example. We have 4 cases, and on the test, I'm just being honest with you, I pick one of the cases. There's only one problem on the test. I actually just made the test last night. So I pick one of the cases. It could have a mixture of the cases, or it could just be one of the cases. So in other words, you gotta know them all. Cool? All right.
I have a quick question.
Uh-huh.
When you're putting the numbers at the bottom, like for our final answer, does it matter where A and B go?
Well, it all depends. Like, look, for example, it does matter. For example, if I put a over x minus 1, then I have to make sure that whatever I get for a, I put it over that, right? If you, for example, decided to put a over x plus 2, and then the b over the x minus 1, then you would have had these numbers flipped. Like, the numbers are not going to change. They're just going to have be flipped. You just make sure you put them in the correct location. That's it.
Okay, so
So,
it does matter.
It doesn't matter. So basically, as long as you follow whatever you are following, like as long as you make sure that if you put A over this and B over that, and that's what your algebra is doing, then you just make sure that you put that back into the place that you put A and B. Cool?
Okay, okay.
Sweet.
Yeah, makes sense. Thank you.
All right. Now, the next example, I want you to try. So I'm going to go ahead and pause. I'm actually recording. So I'm going to pause this video, and then I want you to give it a shot, okay? So we've got x plus 7 divided by x squared minus x minus 6. So once again, you're going to decompose the fraction. So give it a shot. If you get stuck, let me know. All right, let's talk about it. I think we should be done. So hopefully you were able to factor this out into x minus 3 and x plus 2. Again, remember the order in which you write those doesn't matter. They are linear, they are different, so therefore we can have different constants on the top. By the way, sometimes they could end up being the same number, but you don't know that, so you still put different values up here. Cool? So I multiplied a by x plus 2 and then the b times x minus 3 so that I can get a common denominator. I tried the value of negative 2 so that I can make the a go away. Negative 2 plus 7 gives you 5, and then negative 2 minus 3 gives you a negative 5. B, so negative 5b equals to 5 means that b has to be a negative 1. I tried the value of 3 so that I can make this factor go away, which gives me a 5a is equal to 10. Divide by 5, that gives me that a is equal to 2. Therefore, I have 2 divided by x minus 3. And now this is one thing I do want you to do. As a pre-AP class, I would expect you to know this. I know that you put a plus here and you got minus 1, right? Well, plus and minus should give you a minus. So I would expect you to turn this into a minus. Okay. However, every time you're doing this process of breaking up the fractions, always put a plus here. If you happen to get a negative on the numerator, then you can change it on your answer. Cool? All right. Any questions about distinct linear factors or this example for that?
So I got the same thing as you, but for some reason, like I still got minus 1 over x plus 2 and 2 over x minus 3, but I got b equals 2 and a equals negative 1. That doesn't really matter, does it?
Well, that's because you probably had this different, like you probably had a over x plus 2, and then you have b over x minus 3.
Okay.
Right? Is that what you do?
Yeah.
Yeah, that's fine. And that's what I think so. I don't remember if it was you or someone else asked me. It's gonna, I mean, like our values could look different. Like my a could be different than your a, but that's because in your case you put a on the other factor. Cool? All right.
Thank you.
Now we're ready for our second case for the day and our final case for the day, which would be, okay, they're still gonna be linear, but what happens if they're not distinct anymore? You with me? So in other words, what if some of them are repeated? Okay, so that's case number 2. Case 2, it's repeated linear factors. So that would mean that, for example, you have something like this, where you have one of the linear factors, let's just call that okay. By the way, P and Q are just numbers, right? So that's a linear. Do you guys agree? It's to the power of 1. It doesn't matter, right? So this could be like 2x plus 1. Are we okay with that? But let's pretend that this px plus q happens twice, or like 2x plus 1 happens again. So what you're going to do is you're going to put it on the exact same factor on the next fraction, but you're going to square it. And you're going to have a different number on top. And hypothetically, let's say that this px plus q happened 3 times, 4 times, 5 times, 6, it doesn't matter. Let's say it happens n times. What you keep doing is basically you keep writing the exact same factor, but you keep increasing the power. So I'm going to call that the nth power. So this one's a little confusing. It's better to see numbers, but this is really what's happening. You basically keep rewriting the same factor, and you keep increasing the power until it matches how many times it showed up. Okay? But one thing to notice, what you have on the numerator is still a constant. Okay? Now, this is going to contradict a little bit of what I said earlier, because if you think about it, if you have whatever you have here and you square it, that becomes a quadratic, right? And then you're like, well, wait a second, you said that the reason why we had a constant here is because whatever we had in the denominator was linear. But this one's going to be quadratic, and like hypothetically this one could be like 5th power. So why is that a constant? Well, it's because even though it's a quadratic, the actual core of this, in other words, this happens to be a perfect square, what's on the inside is still linear. And that's why you're still going to have a constant there. Okay? All right. This can get a little confusing, so let's just go ahead and try an example. Okay? And I'm going to do a very heavy example. So ask questions, please. The algebra is going to get nasty on this. Are we ready?
Could you really quickly go back one page? Because I just wanted to check if I got all the things.
Okay. So I have a question about case 2. Like it says that like a is like a to an, and then you use that n as an exponent for px plus q.
Mm-hmm.
What is that n? Is that like the number? Like what number?
Like for example, like if you repeat it 3 times, then this n would be 3. If you repeat it 4 times, then n would be 4. So basically, let's just hypothetically say that you had a fraction, right? And then you factored it already, and you found out that the factor was x plus 1 to the 4th power, and then x minus 2. So in other words, this thing was to the 5th power original. You're with me? So what that would mean is that you would have to write this one 4 times. So 1, 2, 3, 4, and then this one time, 5. Okay? Now, I'm going to start out with the easy one. So this is minus 2, so I'm just going to do x minus 2. So this looks exactly like we did on the first 3 examples, right? Now this one gets repeated 4 times, agree? So what you do is on the first one, you're going to put x plus 1. On the next one, you're going to put x plus 1 squared. On the next one, you're going to put x plus 1 cubed. On the next one, you're going to put x plus 1 to the 4th. And then they're all going to be constants, x plus a, b, c, d, and e.
But whenever you do that, whenever you put that exponent there, don't you increase the original value on the equation on the left?
No, because think about it. Look, and that is what a lot of students get confused. Let's say we wanted to get a common denominator, right, to go backwards, right? I don't really care what's here right now. It doesn't matter, right? If I wanted to get a common denominator, this fraction right here, I would have to multiply by what?
X plus 1, then x plus... Wouldn't you just multiply that by x plus 1 to the power of 4?
Exactly, because I'm trying to get here, right? So all I have to do is multiply this one by x plus 1 to the 4th, and I'll have this side, right? What about this one?
X plus x minus 2
Uh-huh.
to the power of 3.
And then x plus 1 to the power of 3. Agreed? And then this one would be x plus 1 to the power of 2, and then an x minus 2. And then this one would need an x minus 2, and then just an x plus 1. And this one would only need the x minus 2. The mistake that a lot of kids do is, and I think this is where your face still kind of looks a little confused. Here's the mistake that a lot of kids do, and please don't do this. They take this one, and they multiply by this one, by that one, by that one, and by that one. Because they're like, okay, I need a common denominator, so I just got to multiply by the denominators of all the other ones. And then, yes, I agree with you. By you doing that, now you're like, what, 4, 7, 9, 10. Now you're on the 11th power. And we were never there. So when you have repeated things, you got to be careful. That technique of getting a common denominator is not going to work for this. You got to look at the left side and ask yourself, okay, I need this denominator. So what do I need to multiply this so I can get that? You with me? And then everything balances out, I promise.
So like in this case, you would probably do x minus 2 times x plus 1 to the power of 4, and then x plus 1 to the power times x to the power, minus 2, and then
X plus 1 to the power of 3.
Okay, so like you just add, like there's not a single amount of values, like there's not a single amount of x plus n that you can have.
Correct. It's going to look different for each one of them depending on what you have.
Okay.
Cool? All right, let's try out an example. So, let's say that you have the following fraction. So you've got that, and I'm going to be nice enough, because I'm going to be honest with you. I could give you this all multiplied out, but I want to focus on the decomposition part. That's the difficult part. You guys should be able to factor at this point. So we're going to skip those steps, and I'm just going to say, okay, here's what I have. Cool? All right, any questions on that part? It's already factored. There's nothing to do. Agreed? Okay. How many fractions should I have and why?
4.
Four.
Because you have 2 x's into x minus 2.
Very good. You should have 4 fractions. Okay. Because this right here, I know it may confuse a lot of you guys, but that's the same thing as saying x times x, right? And then this is the same thing as saying times x minus 2 times x minus 2. So I have 4 factors, 4 fractions. Cool? First fraction, what should I have on it? On the denominator. Second one?
X.
And that's where you gotta be careful, because it's repeated, right? It's repeated, it's the same one, right? You have to go up by a power. Cool? So the first one's gonna be to the first power, and then the second one's gonna be to the second power. Cool? What's the third fraction gonna have?
X minus 2.
X minus 2. And the next fraction?
X minus 2 squared.
Good. Now hypothetically, let's just make sure. If there was a third one, let's say there was another x minus 2, then you would have to have another fraction, and what would that denominator be?
X minus 2 to the power of 3.
X to the power of 3. Do you guys get what's happening? Now, decision time. What goes on the numerator? Well, this is linear, right? Cool. And this is where I lose some people. They're like, well, that's a quadratic. Well, no, remember, technically, I mean, I'll put parentheses. Technically, right, this was a repeated linear, right? The inside is linear, so this is still going to be a constant. Cool? That's linear. That's going to be a constant. And once again, a lot of people just argue this. Well, that's a quadratic. Okay, once again, what's on the inside? Can the inside be linear? Yes, the inside is linear, right? So it's going to be a D. All right. As I'm ready to answer this.
So it only matters if the inside is linear. If you have something on the inside that's not linear, then it wouldn't be a constant, right?
Exactly, and that's what we're going to talk about on, what's today? Tuesday, so on Thursday.
Thursday.
Cool?
Okay.
All right. So now,
Wait,
yes.
That's because when you like multiply the thing on the top, when you get the common denominator, it cancels out to just a linear thing, right?
When you multiply on the numerator, it cancels. You mean like the denominator to be linear? Is that what you meant?
Yeah.
Not necessarily, man. Once again, it's like another thing from calculus. Like, really, the reason why I'm teaching you guys this is because you're going to need this skill for calculus. And you're going to need this for something called integration. And then, well, there's just way too much to it, honestly, to talk about it. But when you try to do that, I don't really care that this is square. What I care about is that this is linear. That's really the reason. Cool? All right. Now, here's where I want you to think before you get started. If you do a system of equations here, how many equations are you going to have?
4.
4. Which means you would have a system of equations of 4 unknowns with 4 equations. So if you're going to do this with system of equations, you've got to be really good at system of equations. That's all I'm trying to say. Cool? All right. So here's what I'm going to do. I'm going to go ahead and skip that step of the common denominator, right? Because we're going to get a common denominator. And I'm going to go straight to the numerator. Okay. What do I need to multiply the first fraction so that I can get this denominator? 8 times what?
X and x minus 2 squared.
Very good. What do I need to multiply the second one? So the b.
X minus 2 squared.
Very good. What about c?
X minus 2 and x squared.
So x squared, x minus 2. And then finally, d would have to be multiplied by
X squared.
X squared. Anyone need help with that part?
Wait, why didn't you put the x squareds on like all of the other ones? Why is A only x and then B doesn't even have an x value and stuff like that?
Cool. Look, we want this fraction right here to have this denominator, right?
Mm-hmm.
So you already have one x, right? So if you have another x, then you're going to have an x squared.
Okay.
And then you don't have any x minus 2,
okay,
so I got
see,
x minus 2 squares. And then on the second one, you already have the x squares, so all I need is the x minus 2 squared. And then on the
okay, that makes
cool.
a lot more sense.
So
okay,
this is
thank
my
you.
technique for you guys. Instead of looking on the right side for the common denominator, look at the left side to help you. Look at what you have versus what you need, and then just write down what you're missing. That's really what the easiest way to go about this. Cool. I have an x, which means I need another x, and then the x minus 2 squares. I have an x squared, which means I'm missing the x minus 2 squared. I have an x minus 2, which means I'm missing the x squared, and I'm missing the one x minus 2. And then for the last one, I have an x minus 2 squared, which means all I'm missing is the x squared. Cool?
I'm still kind of confused. So, what are you trying to, so, are you multiplying the value, like, are you multiplying A, B, C, and D by the values that would make x squared times x minus 2 to the power of 2?
Correct. I'm getting a common denominator. Look, I'm just skipping that step, but look, here's where you're at. That's what I did. I got a common denominator. And how you can check your work is very quickly. Look, if you did this correctly, this cancels out. One of the x's cancels out, and it leaves you just with one x on the denominator. So that's what you had, right? If you cancel this out, it leaves you with b over x squared, which is what you had. If you cancel one of those out with one of those out, and both of those go out, it leaves you just with x minus 2. And then if you cancel the x squares, that leaves you with d over x minus 2 squared. So that's how you know that you did this correctly.
So you're just pretty much just multiplying the values to make up. So does A technically equal X in this case or something like that?
No, we've got to investigate all that. We're just coming up with the expression that we need. So at this point, the expression that we care about, now that the denominators are the same, what we care about is this. This is what we have. Which is the numerator. That's where we're going to be able to figure out what A, B, C, and D is. So I have no idea what any of those are yet. Okay? Now, I want to use the technique that I've been using to make my life easy. Okay? You can start with a system of equations if you want, but I highly don't recommend it. So, what value of x can you use to make some of these things go away on the right-hand side?
0 and 2.
Okay, so I'm going to use 0, and then I'll use x equals 2. Is there any other values? No, which means if there's 4 unknowns, I'm not going to be able to find all 4 of them. But hey, finding 2 of them is better than knowing none of them. You with me? Okay, so if I plug in 0, 0 plus 1 gives you 1 is equal to. If I plug in a 0 right here, that's going to make all of this go away. Do we understand why?
Yes.
Good. If I plug in 0 here, what's going to happen?
You get negative 2 squared.
So you're going to get negative 2 squared. So negative 2 squared gives you
4b.
positive 4b. Okay. What happens if I plug in 0 right here? You get a 0. And lastly, that one should be obvious. That gets you a 0, right? Okay, so look at that. It did exactly what we wanted it to do, right? It got rid of everything except for one thing, which in this case is 4b, which means that b is equal to 1/4. Are we okay with that? All right, now we're going to try 2. Okay, if I plug in 2 here, that gives you a positive 3. What happens if I plug a 2 on the first terms right here? 0, 0, 0, 4d.
Sorry, whenever you did x equals 0, where did you get that 0 from? Did you just take that x squared?
I chose it. So remember, my technique is you choose values that make things go away. And the reason why we chose 0 is because it would make this go to 0, that go to 0, and that go to 0. So it's very strategic. It wasn't just random numbers. We chose 0 because it makes things go away. We also chose 2 because it makes that go to 0, that go to 0, and that go to 0.
Okay, thank you.
Cool? So now, if he makes all that go to 0, and then the last term he makes it go to 4d, what is d?
3/4.
3/4. All right. Anybody lost? Anybody need help? Okay. Well, we only found what B and D is. We still need to know what A and C is. So, suggestions. What can I do to figure that out?
You can use the system of equations.
Yeah, we're going to have to. It's unavoidable. So, earlier somebody asked me, will this always work? Well, it worked, but it just didn't help us find everything. So, but what I do recommend is, you know what B and D is, so now you no longer have a system of 4 equations, you're going to have a system of 2 equations. Agreed? So I'm going to plug these values in. So I'm going to have x plus 1 is equal to, we don't know what A is, so I'm going to leave that alone. So AX, x
Wait,
minus
I
2.
have a really quick question.
Yep.
Could you not plug in the B and the D and then solve it just to make it easier?
Yeah, that's what we're going to do. So that's why I'm going to rewrite it. So I'm going to plug in plus, and then the B is 1/4, so it's going to be 1/4 x minus 2 squared. We still don't know what C is, so we're going to leave cx squared x minus 2. And now we know that D is 3/4, so that's going to be 3/4 x squared. So now, as you can see, now all we need to figure out is A and C. Okay. Question for you. So on the first example that we did as a system of equations, what did I do first to figure out the system of equations? You're going to have to multiply everything out, combine like terms, and then get your system of equations. That sucks. That's a lot of work. So let's get smart. That's too much work. I don't want to do that. How about I continue to use my technique? But it's not going to help me cancel things out. It's just going to help me not multiply everything out. You with me? So choose wisely though. You can no longer choose 0 and 2. Do you understand why? Yeah, and even if you choose them, guys, it's going to cancel out A and C, which is what we want. If you plug in 0, it takes A away and C away. That's what we want. If you choose 2, it also cancels that out, so it doesn't make any sense. But I also don't recommend for you to choose like, I wouldn't choose 10. I wouldn't choose like 15. Choose numbers that are easy to deal with. So we can use 0 and 2. What do you want to use?
1.
Let's use 1. Okay, here we go. 1 plus 1 is 2. All right. Can we do mental math? Yes? All right. What's 1 minus 2? Negative 1. Squared, positive 1, right? Times 1 will be positive 1. Times A would be A. Are we okay with that?
Yes.
So that's going to be
Why
it.
did you do x equals 1? Like, why did you plug in 1?
Because 1 is really easy to deal with.
So you could put it like, obviously I'll do 1 and stuff, but you could do practically any value.
You can do any value that you want.
Okay.
All right, so now I'm going to do 1 on the second one. So 1 minus 2 is negative 1. Negative 1 squared is positive 1. Times 1/4 is 1/4. Cool? All right. C squared, so that will be just C. And then 1 minus 2 gives you a negative 1. Negative 1 times C gives you negative C. And then for the last one, 1 squared is just 1, so that gives you 3/4. Right? So now I have a 1/4 and 3/4 that is equal to 4/4, which is equal to 1, right? And then if I take it to the other side, that would just give me 1 is equal to A minus C. Are we okay with that? Okay. I need another x value. X equals what? What do you want to try?
We do 0?
We've already done 0. So you can repeat values. You've already done 0, we've done 2, and we've done 1.
3.
We can do 3. We can do negative 1. It all depends what you want to deal with. So let's say you did 3. So you mentioned 3. 3 plus 1 is 4. Is equal to. Alright. 3 minus 2 is 1. 1 squared is 1 times 3 would give you 3a. Cool? 3 minus 2 is 1. 1 squared is 1 times 1/4 would be 1/4. Cool? 3 minus 2 is 1 times 3 squared is 9. So that will be 9c. Cool? And then 3 squared would be 9. 9 times 3 is 27 divided by 4. Are we good so far? Alright, so I got 27/4 and 1/4. That gives you 28/4. Is that divide evenly? What's 28 divided by 4? It's 7, right? So from here I get a 7, agreed? So if I take it to the other side, what do I get?
-7.
Negative 3, because 4 minus 7 would be negative 3. Cool? So negative 3 would be equal to 3a plus 9c. Are we okay? Any questions of how I got those? So now I've got a system of equations. Do you guys see it? I have 1 is equal to a minus c, and then I have negative 3 is equal to 3a plus 9c. What do you want to do to solve this?
Multiply by +9. We can multiply 1 equals a minus c by +9.
Okay, so you want to multiply that one by 9, so that gives you 9 is equal to 9a minus 9c. I'm totally cool with that. And then what do you want to do?
Can't you just bring over the 9a? Well, oh, you could just cancel out 9c.
Good, you're going to add them. So we're going to have negative 3 is equal to 3a plus 9c, right? So we're going to add those two expressions, right? So 9 plus negative 3 gives you a 6. 9a plus 3a gives you a 12a. Negative 9c plus 9c gives you a 0, which means that a is equal to what, guys? Very good. And now that you know what a is, you can go back to this one right here, right? I think that's the easiest one. So we know 1 is equal to 1/2 minus c, right? So if I subtract 1/2, that gives you 1/2 is equal to negative c, which means that c is equal to negative 1/2. So I'm all over the place. There's a, there's c, there's D, and there's B. So we've got all of the values that we were looking for. Are we okay? But what's my final answer?
You have to plug in those values back into the original.
Okay, so let's go back to my original. So here was my original, right? So what was a for us? A was 1/2, so we have 1/2 over x, right? And then what was b for us? B was 1/4. So plus 1/4 over x squared. And then c for us was negative 1/2, so that means it's going to be minus 1/2 over x minus 2. And then d for us was positive 3/4, so it's going to be plus 3/4 over x minus 2 squared. Yes? But I don't like answers like that, especially for a pre-AP class. Fraction within a fraction, not happening. How am I going to clean that up?
You multiply the fractions by the denominator, but reciprocal.
So this first one is 1/2 multiplied by what?
X.
Not x.
1 over x.
1 over x. Do we understand why? Technically this is x over 1, so the reciprocal would have to be 1 over x. Technically this is all over 1, right? You guys with me? Okay, so what's the second fraction? So plus 1/4 times 1 over x squared minus 1/2 times 1 over x minus 2 plus 3/4 times 1 over x minus 2 squared. By the way, for those of you, I know that there's a lot of you guys that could have done this. I'm showing all this extra work. You do not have to show all this extra work if you know how to clean this up, okay? Without having to show all of this. So final answer for this would be 1 over 2x plus 1 over 4x squared minus 1 over 2 times x minus 2 plus 3 over 4x minus 2 squared. Do not multiply the denominators out. There's no need to. Leave it as it is. Cool? And that would be a repeated linear factor example. And that's all I've got for you today. Honestly, you know, for you to be successful in this, you got to practice them. Okay? So the homework, make sure that you do the homework. I do have more examples, but I don't think we have enough time. We only have 15 minutes left in class, and as you can see, this can be time consuming. Cool? So